Robotics Pathway 2026 Rollout. Again, this webinar is the one that is designed for administrators of CTE and CTE support staff. My name is Brent Kern. I'm one of the education consultants for computer science, IT, and technology education at the Department of Public Instruction. All right, so let's go over some course information. You can view the course information today on the 2627 Future Course Management System. All right, so where is this course located? We are going with the new advanced CTE framework next year. So we will have the cluster groupings, the clusters, pathways. So cluster grouping for this one, you're going to find it under connecting and supporting success. The cluster is digital technology and computer science. The pathway is a course called robotics. Your prerequisite option is going to be CA21 Robotics I, followed by the concentrator CA22 Robotics Level 2. Course descriptions, typically you read it as a whole paragraph, but I put in this chart so we can kind of see the difference between level 1, level 2. So in level 1, they're going to design robotic systems. And then moving into level 2, they're going to do advanced robotic mechanisms. Level 1, they're going to build autonomous tasks, whereas in level 2, they'll take those tasks and turn that into an autonomous routine. Level 1, again, they're going to troubleshoot. They're going to do some hands-on experimentation with their extra components. Whereas in robotics level 2, they're going to integrate more electronics, and they're going to use those to tune some techniques for that robot to improve its performance. And then, of course, with any of our courses, they're going to gain the knowledge and skills for the entire pathway. So, general information for this course, Mike Renee is going to be the course lead consultant. That is effective July 1st. The course status for both will be pilot. Both will have a local proof of learning. Both are 135 to 150 hours. The recommended maximum enrollment is 20. And both of those will meet the computer science graduation requirement. The robotics level 1 can be offered in both middle and high school, whereas the level 2 just meets the requirement, can only be offered in high school. Course outcomes. So these are the essential main ideas that the students should learn throughout the course. So robotics 1, this is something that could be shared with parents, students, and your community. Level 1, they're going to build a working robot using motors, gears, simple electrical parts. 2, they're going to write basic code. They're going to make the robot move, and it's going to complete some simple tasks. And then 3, they're going to use basic sensors so the robot can detect and respond to its surroundings. And then with level 2, they're going to design and build advanced robots with parts such as arms, lifts, or drivetrains. They're going to combine sensors and electronics to help a robot make decisions. They're going to program a robot to work on its own without using a remote. And 4th, they're going to make a robot move accurately by using control systems. Right, so those are our outcomes. Here's the course standards. I'm not going to read these out to you guys, but with all of our CTE courses, the first 2, these are our CLES standards. And then with 3 through 7, we progress throughout the course. Then robotics level 2, again, standards 1 and 2. These are CLES standards that we see in most of our CTE courses today. And then 3 through 7 is how students will progress through the course. All right, curriculum guides. These documents will be published on the CSIT Moodle in the upcoming days. I am missing one checkbox from this, and I believe it is the cover. We have seen the cover, we've approved it from graphics. They are purchasing the images. I believe that is the last piece that is holding us up from posting this. I've gone over both guides 100 times. Leadership has approved everything. We just do not have the cover. So I'm assuming that that could come any hour, and hopefully I'll be able to post that in the upcoming days. I cannot give you an exact date today, but I do have some of that material in this slideshow. So CTSOs, all of our guides start with the CTSOs. Since the first course can be used with middle grades, we've aligned it to the challenges that our middle grades CTSOs have. And then the licensure for this course is going to be the Technology Student Association, the Future Business Leaders of America, and Skills USA. Those are our middle grades events. We also have our high school alignment. And then both guides will have some general platform guidance, followed by some vendors that you can reach out to purchase robots and or curriculum. So our general guidance for CA21 Robotics I is that it should allow the student to do some sort of mechanical system that uses motors, gears, and structural components. They need to connect and safely use electrical components, write and test basic code for movement and task completion, integrate simple sensors for the environment detection. Whereas in level 2, the guidance changes a little bit. They need to do some advanced robotic mechanisms, such as an arm, a lift, or a complex drivetrain, integrate and interpret data from multiple sensors, develop autonomous programs using structured logic, and apply control methods to improve precision and movement efficiency. And then those vendors would be, the first of which is First Robotics. For this, we are most likely talking the First Tech Challenge. I know many schools participate in First Robotics. Many schools do the First Tech Challenge. Many schools will do the other challenges within First Robotics. It is appropriate to use First Robotics in general. It's appropriate to use the Tech Challenge or anything higher than that. Now, keep in mind when you go to the higher competitions, that cost becomes astronomical. And often the high school teams are sponsored for that. So I'm not sure how that would exactly work in a classroom environment. Tech Challenge is a cheaper entry point and a better use in the classroom. Parallax Robotics. They do have some robots that use gears and motors. They include some sensors. This is very basic. I would not typically recommend this, but if you're going to teach level 1 in a middle grades classroom, this may be a good product to begin the students with before you move them into something a little more challenging. Up next is going to be Pitsco Education. Pitsco sells the Tetrix Prime system and a few other systems. This is your all-in-one kit. You've got curriculum, you've got all of the parts, all of the motors, the controllers, the batteries, and whatnot. And we also have Rev Robotics. Rev is a partner with First Robotics. They sell classroom kits, such as the EDU Kit V2. They have their own curriculum products. Right now, if you go to their website, you can purchase their curriculum for free. They have a coupon code that I will paste in the chat here for you to go ahead and review some of their curriculum and download that. All right, so the link is in the chat for that. The next system, and this is the one I believe most schools that will have that have offered robotics in the past. So again, robotics in the past was an LCO. We're just moving it over to state managed for the enrollment. We're also open-ending it, so you no longer have to use VEX Robotics. You can use the system of your choice. So in the previous LCO, everyone used VEX Robotics. Some used VEX EXP or VEX V5. Some use VEX IQ. The difference between those, VEX IQ is made out of plastic. When you move into EXP and V5, that's more of your high school age population. The components are metal. You're going to have a longer lasting product. Many of our schools participate in the VEX Robotics competitions. Each year, those competitions, the field elements typically change. So you can keep those old field elements from the past seasons for your classroom use. There's nothing wrong with those elements. Just because the game changes, you can save that stuff for your classroom use. So I'm sure many schools have kits of old equipment sitting in the back somewhere that you can pull out for these classrooms. And then any other system possible. Robotics is becoming a popular area, so I could see any new system coming out. I could see a very advanced teacher going the rogue robotics method, where the students design the stuff from scratch. You can 3D print, you can wire motors and sensors and whatnot together to build your own system. The choice is up to you guys at the local level. All right, so throughout the course, we have essential questions for every major piece of unpacked content. The curriculum guide itself is about 55 to 60 pages for both level 1 and level 2. You're going to get essential questions, unpacked content, teacher briefs, and teacher resources for everything. So first, essential questions. Here's a typical one that you would see. How does documentation support planning, collaboration, and iteration in robotics? So as an administrator or a CIMC, this is how you would support your teachers with that. You're going to anchor their instruction so they ensure they revisit the question throughout the lesson cycle, not just at the start. Promote inquiry over answers. So as a CIMC, you would tell your teachers to encourage classrooms where students start to explore, test, and refine ideas, not just memorize something. Students should be able to explain how and why. So you would tell them to look for their evidence in their student work. During walkthroughs, you could ask, how is this lesson helping students? So you should tell your teachers to use this tool as something that they would need during an observation and feedback. And then this also builds teacher clarity and consistency because the questions and planning time for PLCs should be, how do you align this question to your unpacked content across your classroom? So leaders would ask, how is the essential question being used? And teachers are going to ask, how am I using this in the classroom right now? Here's an unpacked content example, right? We're on letter K, which means I have every letter of the alphabet through K. So K, understand how documentation supports planning and improvement. And then under that, we have some sub-concepts. So an engineering notebook routine, building documentation, troubleshooting documentation, and team documentation that supports collaboration and continuality. And under that, we have broken that down even more. So like, perhaps your teacher doesn't know what an engineering notebook is. Maybe they would put the dates, the versions, the decisions, and the results under that. For build documentation, they could include sketches, parts lists, wiring notes. For troubleshooting, they need to include symptoms, hypothesis, a change, and a result. How do you support that to your teachers? So ensure the depth is moved beyond vocabulary. Look for instruction that moves past naming parts towards explaining their function and purpose. Prioritize conceptual understanding. Students should know how these things work, not just list the mechanisms. Support coherent progression. Ensure teachers build from the smaller components up to the bigger components. Look for application and context. Students should apply concepts in builds, not just learn them in isolation. Use it as a walkthrough lens. Ask, are students explaining how and why these mechanisms work in this robot? Ensure access to materials and experiences. Kits, robots, simulations must be available for hands-on exploration. Teams should align and promote consistency across classrooms. Teams should align on which mechanisms are emphasized and how deeply. So leaders ensure the conditions for quality. Teachers create the experience of learning. Here's an example of a teacher brief. So standard 1 or standard 3 establishes the safety mindset and the planning mindsets student will rely on throughout the course. Students should understand that safety is a routine practice connected to every stage of robotics work, including building, wiring, programming, testing, troubleshooting, and cleanup. The teacher should explicitly teach and reinforce expectations for safe behaviors, safe testing practices, and safe handling of tools and equipment. The engineering design process is part of this standard because planning and documentation reduce preventable errors. Students should understand how criteria and constraints guide decisions, how prototyping supports instruction, and how testing results support improvement. Documentation, routines such as engineering design notebooks, build notes, checklists, and troubleshooting logs help students communicate decisions and support safer and more efficient iteration. So for each standard, there is a teacher brief. The teacher briefs are at least an entire page, if not 2 pages, of walking the teacher through a best practice way to go about this in their classroom. So again, this is how you can support your teachers as they work through their teacher briefs. Prioritize conceptual understanding over computation, so students should be able to explain the trade-offs. Look for systems thinking. Instruction should connect structure, power, and mechanisms, not just teach them in isolation. Expect evidence-based reasoning. Students should justify their design decisions. Remote inquiry-driven classrooms. Learning should center on investigation and experimentation, not just lecture and delivery. Support a clear learning progression, observation, controlled testing, application. Look for purposeful data collection, students gathering and using measurable data, such as time, distance, success rate, or load. Ensure access to iterative experiences. Students need time and materials to test, revise, and then improve their design. Use walkthroughs to probe learning. Ask, what evidence do students have and why their design works? So teachers, leaders, you would look for evidence of inquiry, but the teachers will do the design investigations, guide testings, and require explanation. And then we have instructional resource for everything found in the unpacked content. These are going to be resources from our educational partners, such as our professional organizations. You're going to see a lot of stuff from Teach Engineering. You're going to see a lot of university things, government things. These are where your teachers will go. We have things from First Robotics, Vex Robotics. So these are sometimes lessons. These are activities. These are sometimes PowerPoints. If the teacher doesn't know a certain topic, that's where they can go to learn about the topic. So we have that for all standards in this. And of course, this is going to be a pilot year. So pilot supports. We're going to have third-party curriculum crosswalks. I have sent this to First North Carolina, Pittsco Education, Rev Robotics, and Vex Robotics. Once the partner completes those crosswalks for their products, we will put those up on the CT Hub. Pathway Teacher Lead, those applications have launched. They launched on April the 16th, and they're due by April the 30th. Teachers will need the support of their building principal and their CT director. We will announce that new Pathway Teacher Lead during our summer conference. So if you know any teacher that's potentially going to teach this course, they've been a robotics coach, they know robotics, please send them our way. I looked at applications, and I think so far we have one applicant. I would really like to get a pool of applicants because this is one of our new pathways that's going to need a lot of support during its first year. This is a paid stipend position. Of course, with all of our courses launching in pilot status, our team will host check-in meetings and pilot surveys throughout the upcoming school year. We put tentative on this because we haven't nailed down the dates for that school year yet. Once we get past summer conference, we'll have the time and the capacity to put all of our 26, 27 school year dates out there. And of course, every Tuesday afternoon, we have held CSIT office hours. This is another place where you guys can come in, drop in, ask questions about the computer science graduation requirement, ask questions about our pathways, ask questions about our K-12 integration standards. We're here almost every Tuesday. At least someone from our team shows up. And of course, you can always send us an email. You all have my email. You all have Mike's email. If you don't know who to send the email to, you can send it to csit@dpi.nc.gov. That'll go to our entire team, and the best person that can respond will respond to that.